Okay, this is going to cover everything that our pacing guide had us cover in Chapter 6 to kind of help for the final in algebra. So these are the property of exponents. You can look at Chapter 6.1 to see all of them, but this will get you ready for the final for the most part here. So the first thing we're going to look at is the product of powers property. Remember, when you're multiplying exponents, you add them. So I'm not going to draw things out and show you an expanded form or give you these lengthy explanations on this. I just want to quickly show you how to do the problems, as there's a lot to do. I'm not going to do what I normally do and break it down. So when you multiply, you're adding. So it's 3 minus 5, which would be y to the negative 2. But then if it's a negative exponent, does it stay or does it go? It goes. So it'd be a 1 over y. 1 over y. Second. So the quotient property of powers, the quotient of powers property, when you divide, you subtract. It's like saying 4 take away 7, right? If you were to write it out, x to the 4th minus 7 would equal x to the negative 3. So the answer is 1 over x to the 3rd. You can think of it a couple ways. 4 take away 7, 7 is the bigger number, so the answer is going to be on the bottom. Or you can think of it, it's equal to negative 3, so it should go and be in the denominator. This third power is going to go to both. But anything to the 0 power is just a 1. So it's really just 1y squared. But if it's 1y squared, we don't have to write that. We can just write y squared. And then you have a power to a power. And when we have a power to a power, then we multiply. So it would be y to the 6th. And then we have an example of a negative exponent here. Now this negative exponent is going to hit everything, right? So the first thing I'd like to take here is the negative. The negative is going to make sure everything goes. So what's on top is actually going to go to the bottom. What's on the bottom will go to the top. So let's go ahead and work this out here. 2 to the 2nd power would be 4. Power to a power is multiplying. That also would be 4. 5 to the 2nd power would be 25. I'm right on top because it's going. Y to the 4th to the 2nd power would be y to the 8th. That's the answer. So now we're talking roots. I showed you guys in class how to do it with a calculator. I'm just going to do it quickly here. So what times what times what would be 8? Well, the answer is 2. 2 times 2 is 4. 4 times 2 is 8. So the answer is 2. What times what times what times what times what would be a negative 243? I believe that's a 3. 3, 9, 27, 81, 243. So the answer would be a negative 3. So negative 3 to the 5th power would be 243. It's the inverse of that. When you have both when you have a fraction in the exponents, you have to both do the root and the power. The root, the denominator, is the root. The numerator is the power. So I believe that's a 5. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. So it's 5 to the 4th power. So the 4th root of 625 is 5. But then we have to do the power of it. So it's 125. Now, exponential functions. In order to do that, the first step is to make a table. Looks like my marker's dying. Make it work. And then we choose numbers. So I'll choose a negative 2, a negative 1, a 0, a 1, and a 2. Then we substitute them in and solve each time. So I have a negative 2 here. Just work it out. The negative is going to make this go. So 9, 1 over 3 to the second power. But 1 to the second power is 1, and 3 to the second power is 9, so it turns 9, 1 over 9. You multiply by the top, divide by the bottom. 9 times 1 is 9. 9 divided by 9 equals 1. So if you input a negative 2, your output would be a 1. What happens if you substitute a negative 1 in? Well, you would get the same result as they would go. The 3 would go, so it would be 9, 1/3, but to the 1 power. Anything to the 1 power doesn't change, right? So it's 9 times 1/3. And how do you multiply a fraction by a whole number? Well, you multiply by the top, divide by the bottom. So 9/3, or 3 goes into 9 3 times. And you might already be able to find the pattern. 0 is so easy, you can just do it in your head. Anything to the 0 power is 1, and 1 times 9 is 9. You might be able to see here what we're doing each time. It looks like we're multiplying by 3, so the next number should be 27. And actually a hint that this is a 3 would indicate we're multiplying by 3 each time. So if we were to substitute a 1 in, 3 to the 1 power is just a 3. 3 times 9 is 27. And if we're multiplying by 3 each time, 27 times 3 would be 81. Okay, the last step would be to graph this. I didn't give myself a lot of room on this paper. Let's see if I can fit it in here. So if x were negative 2, y would be 1. Barely there off the ground. If it's a negative 1, it would be a 3. If it's 0, it would be a 9. If it's a 1, it would be 27. If it's a 2, it would be 81. It would look something like this without touching. I was going to do another one, but I will skip it for now. It'll be okay. As long as you remember to make your table, choose your numbers, substitute them in. So this is the last thing we covered, 6.9, solving exponential equations. Since the base number is the same, you make the exponents equal to each other. So x would equal 3x minus 2. Then solve for x. There's a couple ways you can do this. I'm going to take away an x from each side. You don't want x's on both sides. You want to put the variable terms on one side and the constant terms on the other. So I would have 0 equals 2x minus 2. I'm going to add 2 to both sides, and I'll have 2 equals 2x. Divide both sides by 2, and you'll have 1 equals x, or x equals 1, same idea. On this one here, you want to have the same base number like we did on this one, but this is a 1 over 9. One way to fix that, though, is to use negative exponents. Remember, a negative makes it go, right? Then it's still a 9 and a 3, and you want them both to be 3's. So what I would do is I would make it a 3 and say that it's a negative 2 exponent. The negative makes it go up, and the 2, 3 to the second power, is a 9. So it takes care of the 9. Once you have the same base number, you can just make the equations equal to each other. Oops, it's a negative 6, isn't it? So x would equal a negative 8. Okay, looks like I have one more here. This is a more challenging one. You want to have the same base number. So let's say we make this exponent negative to make it a 16. The negative exponent, we're going to multiply by the 3x, so we'll have a negative 3x. But they still aren't the same, are they? But what number could go into both of these? Well, a 4 could. You could argue a 2 as well, but 4 is going to be a greater number. So 4 to the second power, you're going to multiply that by what's already in the exponent, the negative 3x. And this is going to be 4 to the third power. You're going to have to multiply that by what's already there, which is a 2. Then you're going to multiply that whatever the answer of that product is, the product of that by what's already there. So let's go and do our multiplications. We'll have 4 to the negative 6x equaling 4 to the 6th times the quantity of x plus 8. Sorry. 2 times 3 is a 6x. And then 3 times 2 is 6. And now that we have the same base number, we can proceed. We can say a negative 6x equals 6 times the quantity of x plus 8. There is a quicker way than using the distributive property here. I could just divide both sides by 6 and be done really fast. But I'm going to do it the way most of you would probably work it out. So we have x's on two sides. You want them on the same side. So I'll take away negative 6x from both sides. You could have done this a couple different ways. I'm running out of room here. Let's just go to the side. We don't need that much more room to finish this. I'll just rewrite it. Divide by both sides by a negative 12. And you got your answer. So this is all of chapter 6 that we've covered. Hopefully that helps get ready for the final.